Hi everyone. In this video, let's look at how to take a packet capture using a Sniffer Mode AP. Now, the main use case is, if you have to take a packet capture in a wireless environment where you are not physically on site, maybe problem happening in a different branch, far away from where you are, but still you would like to take a wireless packet capture, you may not have someone capable of doing other way of packet capturing. So then you are relying on purely turning one of your access point into a mode called Sniffer Mode. So it is not supported by all the vendors. I know Cisco and Aruba, definitely they have support for this kind of mode. So now since I have a Cisco environment, I will show you how can you do that using a Cisco access point. So now this is my test setup. I already had this. I have some client servicing access point operating on 3 different frequencies in 3 different bands. So now if you want to take a Sniffer Mode packet capture, so now it's useful in the remote capture as we discussed. So now you can convert into a AP into a called Sniffer Mode. Okay, so once you put a Sniffer Mode, and then you can point out where your Wireshark running machine. In that way, the Sniffer Mode traffic, not directly sent by this access point to your Wireshark machine. Mostly it is coming from your wireless controller, because that's where the Sniffer Mode AP registered to, and then it capture all the over-the-air traffic and then send it to a Wireshark running machine. This can be anywhere in your network, even if you have a branch network in a different country, but you want to take packet capture, you may be another country. As long as you have WAN connectivity from your controller to your Wireshark running machine, then you can easily get the packet capture there. So what I will do is I will walk through the entire process. I am using a Cisco 9800 cloud controller, and I will convert a AP into Sniffer Mode and demonstrate this capability. So now here my access point, I have 2 access point. So at the moment I have a client servicing access point. That's what those, channel number 21 here, you can see it's channel number 21 in 6 gigahertz, channel number 149 in 5 gigahertz, and channel number 1 in 2.4 gigahertz. So now that is my client servicing access point. So I have another access point. What I'm going to do is I will basically convert this into a mode called Sniffer Mode. So once you convert Sniffer Mode, it giving the warning that AP will be rebooting. That's okay. We have to basically, when you change the mode, APs typically go to reboot process. In that way, it will take at least a couple of minutes. So we have to wait and see that AP to come back. You can see that AP is now disappeared from my controller, so it should be coming back. So now while it is coming, then I will walk through the process of where my Wireshark running machine is. So now I have my desktop computer. I have this is same client, same sort of device I'm using for wireless testing. So I have some wireless interfaces. This is where I'm simulating the client. So I'm connecting wireless interface here. Now idea is from my controller, whenever it get the Sniffer Mode capture, it will send into the this Wireshark running machine, which is 192.168.125.200, which is the wired connection of this computer. In that way, when you want to take packet capture, so you have to basically take the Ethernet interface of this adapter. Okay, so now in here, if you look at, probably you will see that is the 125.200, which is the Ethernet 2, Ethernet 3 interface. Now if I take packet capture here, so at the moment we are not sending any wireless traffic. So you can see, it generate some other traffic, so sometime whenever you are taking a Sniffer Mode packet capture, you are not interested to see all the traffic see on the your wired interface of the capturing kind of PC. So now what you can do is, you can apply certain filter. In that way, we only capturing the wireless sniffing traffic. Okay. So now here, if that AP come to sniffer mode, I will just pause it for the moment, and I will go and check here. If that AP comes back, you can see that AP comes back. So now it says it's a sniffer mode. Okay. Now what we need to do is now go to the each individual radio band. For example, in here, I have AP 176 in the sniffer mode. So now if I click that particular one, you can see, it's a sniffer mode, and probably you have to enable sniffing on this particular one. I just enable, and I just said, just go and sniff channel number 21. Okay. Now what is the sniffer IP? 192.168.125.200, which is my PC I showed to you. Okay. In that way, sniffing channel, and let's update and apply. Now it says sniffing channel 80 megahertz. So let's double confirm whatever we said, channel 21, which is 6 gigahertz. Sniffer IP status says valid IP. Okay, now if you go to our sniffer, let's see whether we can see any wireless specific traffic. I'm just restarting the capture here. Now if you pay attention, probably I stop the capture now. You can see now we are getting certain .11 traffic. Okay. So now this is the beacon frame, like on channel 21, I have access point. You can see all the detail, all the SSID detail I'm advertising. You can see the wireless traffic here. Now what we want is actually, I want to only get this traffic. I don't want to see other traffic here. Now if you pay attention to this Wireshark, whatever the wireless traffic, you can see the protocol source port 5555, destination port 5000. Okay, it is coming from my control IP address 130.20 and to my computer here, Ethernet interface IP. That's where traffic is coming from. Now if you want to only filter this, what you can do is you can filter by a port number. Okay, so if you pay traffic filter by UDP port either 5000 or 5555, you only able to capture this particular traffic. Rest thing will be filtered down. Okay, in that way, let's do that in the capture, probably in the capture filters. What you can do is, I already have something defined here, Sniffer Mode AP and UDP 5555. Otherwise, if you want to completely do it from fresh, you can apply clicking plus button and simply put the filter expression UDP port either 5000 or 555. Now what I'm going to do is, because if you're using Rockstar Wi-Fi profile, those details should be available, whatever the capture filters I have defined. So I'm selecting that and click OK, and now go ahead and capture. Continue without saving. Okay, so that means I have not applied. Still I can see the TLS traffic. That means I have not applied. Okay, so now capture filters. Probably let me just probably in here, if you select your capture filter, so that may be the proper way of applying. Now I'm applying a UDP 4555. You can see it is with the detail here, Ethernet 3. We are applying that capture filter, and then let's start with that filter. Now you can see only a wireless traffic is I'm capturing. Okay, so now if you want to do the multi-channel capture, so what you can do is, you can go back to the controller, because I only configure the 6 GHz kind of frequency. I need to go and configure sniffer mode channel number here 149. So now you select here, enable sniffing. Now enable channel 149, which is 5 gigahertz. Give the same 192.168.125.200. So if I write and apply and go back to my Wireshark running machine, probably you can see now traffic coming on channel number 149. It appears to be some client already connected. You can see addition to the beacon frame. You can see some other client traffic as well. That means this is data traffic, channel 149. So now if you want to capture 2.4 as well, let's do it like a 3-channel capture. 176 here. Enable sniffer mode here. That's already we did for 5 gigahertz and then 2.4. We'll set a sniffer mode, channel number 1, 192.168.129.125.200. So now I already configured all the 3 channels. So now ideally we should be able to see channel number 1 traffic as well. If you pay attention to channel column here, you can see channel number 1 appearing. It means capturing all these 3 channels. So now sometimes if you have a dual 5 gig radio, sometimes you should be able to capture on the 2 5 gigahertz as well. That's the advantage of having some high-end kind of access point. You have multiple radio in the sniffer mode. You can put all those particular radio into sniffer mode. In this particular scenario, the sniffer AP is not servicing client. That's the only drawback while you're doing this packet capture. That APP only converting into a sniffer. Okay. So now our sniffer already running. So now what we'll go do is we'll take some packet capture and see whether we can see all those details. So now I'm going to connect my test client here, and I will connect to the 3 different SSID. Let's say .1x SSID first. Let's connecting client to .1x SSID. Okay, it says no internet, but still get connected. Okay. Now let's see whether it's connected properly. SSH WLAN show interface. Okay, it says it's not connected, disconnected. So let's connect to a different SSID. Maybe MR and guess. Okay, it got connected. Now you can see I'm connected MR and guess and using OWE, AKM value 18. It's all successful connection, and let's connect now to the PSK SSID, which is a MLO connection, Wi-Fi 7. It can go any of these particular band. That's the advantage of having multi-channel capture. In Wi-Fi 7, you don't know which channel and maybe doing the initial association, how many band, adding to the multi-link operation kind of activity. So you basically have to take multi-channel capture. So now in here, it's connected. Now if I look at the show interface, it connected using channel 21 and channel 149. That means he used 5 gigahertz and 6 gigahertz. That's what client decided to go, and using AKM value 24. Okay, WPA 3%. So let me give another try on .1x SSID. Sometime I'll try one more time here. If not, I have a try to transition mode. Let's see. Yeah, this time it connected. So let's see whether in the detail here as well I can see that connection. Yeah, in this time I can see AKM value 3, which is .1x, using Wi-Fi 7 kind of radio connection, with fast transition enable as well, FT ROM it says. Yeah, in that way I simulate 3 client, and then let's basically stop this capture and see whether you can see all those details. Now in here, let me just expand a little bit. You can see it clearly. So now if you go to your management and association request frame, that's where typically you find the initial client association, because it has like a 210,000 packet. It took some time, to process, but you can see I'm initially trying to connect to mrnx. Maybe this is the initial unsuccessful association, and then I connect to the mrn guess, and then a psk, and again successful mrn association here. In that way, if I want to filter client traffic, this Intel client, that's my client device. So if I filter for, I copy the value and go to my frame filter and apply the appropriate MAC address. I'll just paste that particular value here. You make sure you select the particular association request frame and copy the transmitter address or source address value, copy value, and then go to frame filter and replace this value with your interested client MAC address. So now 545C is my Intel client MAC address. Now you can see around 600 packets traffic from this. So now if I show you this, so now you can see initially client tried to do the .1x, in this particular time. I did not get a successful association. That's why I had to went back, now they were doing, let's say, a success, even though, you didn't really see the client may be disconnected immediately. I can see client on the originally connected .1x success, everything looks okay. And then we deauthenticated, and then we tried the this is sort of a failure scenario. I can see it's keep on trying, authentication, keep on trying that. And this is the second, that's SSID, connecting to the mrn guess SSID. I'm connecting to successfully that, and 4-way handshake. And then I connected to the pre-shared key kind of SSID. So typically, if you're familiar with this color scheme, you will be able to identify those client association. Now this is the final one, mrn1x. So this one should be like, if I go up here, this should be the mrn guess. I'm looking for mrn psk. Now the authentication. So this is like a 1x kind of association. Now this time it is successful. It's connecting 4-way handshake and passing data. Again, reassociation kind of thing. So now if you are interested about what happened to the PSK, I would like to see what happened with that Wi-Fi 7 connection. Now if I go back, why I can't see it here? So if you look at the reassociation request, so my MAC address is different. Okay. So now sometime in Wi-Fi 7, if you look at association PSK, you can see my client MAC address is something called 545F, which is not 545C. So that means he's using a different link specific MAC address for the initial association. So that means I need to basically filter by that MAC address. Let me just copy this value quickly and show it to you. So go back, client MAC filter, and apply for this particular value. So now in here, this is a sort of my Wi-Fi 7 MLO connection. So now you can see still typically SA authentication and then association request response and 4-way handshake. So I noticed due to some reason M2 has not been captured. I saw that particular problem in all the sort of scenario. That's something I noticed while doing this particular test here. So now important thing to basically remember is, so sometime because you are looking my profile, you can clearly see this as a .11 kind of traffic. But let me just put into a default profile. Okay. So once you put into a default profile, you may not see this capture as .11. Why? You will see this as a, you can see even, now it's default showing that as a UDP, because I may have some kind of profile value, it's all automatically know this is this decoding this as a wireless traffic. So now if I right click here, you can see decode as any of this particular frame. So you can see, I'm not sure, maybe I have done this example by default. You will see something like this, okay, because that filter should not be there automatically. I will show you how you see. Now even here this time it's already showing. Now let me just save this capture. File, save as, I will say Sniffer AP. Save, and I will close all these. So this is what I expected to see, okay, because I close and reopen the file. You can see now your traffic will be seeing as a UDP traffic, protocol being UDP coming from the controller IP to your Wireshark running IP. Now to interpret this as a wireless, we need to tell Wireshark, hey, this traffic is omni-peak kind of encapsulated traffic. So what you need to do is you need to right click any of this particular frame, just say decode as, you just say this sig comp is a default appearing here. You just basically need to say, probably the easiest one is basically you can say instead of default, you just change this to something called PeekRemote. If you just look for P, you can see there's something called PeekRemote, and if you click OK, now it will show this particular inner detail. Now you can see the protocol as a .11. Okay, in that way, it's now know how to interpret the inner detail of that. In that way, keep that in mind. If you're not using these kind of configured profile, by default it may appear as a UDP traffic, but as long as you know it's a wireless sniffer mode traffic, you can tell Wireshark, hey, that is that particular traffic. So in my profile, it's already being done. That's why whenever we use my profile, you always saw it as a wireless traffic there, .11 kind of traffic. Okay. So that's it. Basically in that way, powerful method. You can quickly take packet captures, like even the client servicing access point, you can momentarily put into a sniffer mode. When you're troubleshooting some problems, it may be important to get the over-the-air capture. Okay. In that way, I hope, you get some good idea what is the Sniffer Mode AP and how you can do it if you have a Cisco 9800 environment. I will link, I have done some similar kind of posts in the ROS controller, a very similar approach. You can follow that as well if you have ROS controllers like a 5508 older controller model, still supporting the same thing. Okay. So we'll look at some other method, packet capturing mechanism in the next video. Until then, happy learning and keep studying wireless.